So we've worked with the greatest common factor, and we worked with perfect squared trinomials, so that was like this, and we worked with difference of two squares. Today we're going to talk about factor by grouping. However, I don't want us to forget about these three things because sometimes you have to factor by grouping and then do these things in order to finish factoring. Okay, so keep those in the back of your brain while we do the next few examples. So factor by grouping is one of my favorites because it's always pretty easy to see that you're going to do it. Factor by grouping, you're always going to have 1, 2, 3, 4 terms that you have to factor. And so usually factoring is 3 terms. When it's 2 terms, it's usually difference of 2 squares, but when it's 4 terms, you're almost always going to start by factoring by grouping. So that means you group the first 2 together, and you group the second 2 together. Once you've grouped them, now you have to pull out the GCF. That's why I said don't forget about the greatest common factor, because when you factor by grouping, you have to pull out the greatest common factor. So when I'm looking at ax plus bx, I see that they share in common an x, so I'm going to pull that out. And I have a plus b. Now you're probably looking at a plus b and you're like, Ms. Whitaker, they don't have a greatest common factor, there's nothing I can do. Secretly, they both have a 1. So if it looks like there's nothing you can pull out, always pull out a 1. The thing that I love about factor by grouping is if you do it right, in parentheses, you're always going to end up with the same thing, literally the exact same thing. If you don't end up with the exact same thing, you've not done something right. Even if this sign is plus and this sign is minus on accident, maybe, this sign's minus on accident, you still haven't done something right. It has to be exactly the same. Mine end up being exactly the same, so I always write the factor they have in common first, because this factor is now like the GCF. What can I pull out of both this whole piece and this whole piece? I can pull out a plus b. And what do I have left over? X plus 1. There are my factors of this 4-pieced polynomial. Let's do the next example. So this one, again, factor by grouping. You're like, okay, factor by grouping. Here we go. I'm going to group the first 2. I'm going to group the second 2. All right, the first 2 have nothing in common, so I could pull out a 1. This one, let's see, they have an S in common. They have a T in common. So I'm left with an S plus a T. Okay, these 2 should be the same. Oh, they're not. So then you have to think, okay, it's 4 terms. I have to have done something. So now you're going to want to start over. I need to get rid of all of this. There we go. Okay. So you're like, okay, I know it's 4 terms. I know I have to factor by grouping. I couldn't just straight up group things together. So what if I rearrange this and try it a different way? So I'm just going to move 2 pieces around. Instead, I'm going to have s to the 3rd plus s squared t, and then t to the 3rd plus st squared. Now let's see if I end up with the same thing when I factor by grouping. Okay, so this first thing, I can pull out 2 s's, and I'm left with 1s plus a t. Okay, cool. This next thing, I can pull out 2 t's, and I'm left with 1t plus an s. So you get here and you're like, well, they're sort of the same. Ms. Whitaker said they had to be exact, though. Well, the thing about addition is it doesn't matter the order you add things in. This guy could be rewritten to be s plus t, and it's the exact same thing. So technically, you have done it right. With subtraction, though, it won't work. This is addition, and so it works. So I like to write the piece that they had in common. So the GCF of both of these, oopsies, ended up being s plus t. And what do I have left over? S squared plus t squared. Boom. So if it's 4 terms and you start off factor by grouping and it doesn't work, try to rearrange and see if it'll work that time. So this last one, again, you're probably looking, all right, factor by grouping, Let's group the first two. Let's group the second two. Well, there's no GCF with this first thing, so I'll just pull out a 1. We'll see if it works. With this one, I can pull out a -2. And I'm left with u, plus v. Dang it, it's not the same thing. Okay, let's try a different approach. What if I rearranged it? Okay. So Ms. Whitaker said that if we arrange stuff, that'll then work. Okay. Arrange. All right, here we go. This feels better. I think this will work. I can pull a u out. I'm left with u minus 2. I can pull a -v out. I'm left with v minus 2. U and v aren't the same. OMG. Now what do I do? Sometimes, when you have 4 terms and you want to factor by grouping, you're going to have to actually factor another way first. You're still going to do factor by grouping because it is 4 terms. But this guy right here, when I first did this problem multiple times, I failed to realize this is the difference of 2 squares. This is the same as this. I can square root him. I can square root him. There's a minus sign. You have to factor first. U squared minus v squared is just u minus v and u plus v. So trickster. And then I'm left with minus 2u minus 2v. So now you're like, okay, what do I do from here? I don't even know what's happening. This guy, I'm going to pull out the GCF from him, the greatest common factor from him. So I'm again just going to write my u minus v and my u plus v. I can pull out a 2, and I'm left with u plus v. So I'm looking at, I have this piece, and I have this piece. Do they have anything in common? Hopefully you see, yep, this guy, this guy. That's what I can pull out. So I pull out my u plus v, and then you write everything you're left with, because you're left with u minus v minus 2. Who knew this guy was going to cause so much trouble? If you recognize that you can factor something first, go ahead and do it. It might take you a while to get there. It took me some trial and error. But now that you kind of know that this is an option, keep that in the back of your head if you ever see a problem like this.